Hey everyone, I am Aruf Sikshit and you are watching Connect Karush English. Please subscribe, like and share my channel so I will be motivated for creating technical videos like this. So let's get started. Today we are continuing our uh, deep learning project series and this is our part 4, and in this video we are going to discuss how can we create a laptop price predictor with help of TensorFlow. So let's go to our computer screen and get started. So I have already created a Jupyter notebook here right now, and this is install and import dependencies part, and I will write pip install TensorFlow because we have to install TensorFlow. If you run this command in your local PC, then it will be installed. And if you are using with GPU, then you can write this command. And if you are using just CPU, then you can delete this word, and it's like this. So let's create another cell. So here I will simply import TensorFlow as TF and then run this, and it will import the TensorFlow. After it has imported the TensorFlow, you have to load the dataset. Now click on this file button and go here and choose your data. Right now I will simply choose that data, and this is that file. So it's loading, and I will simply create a variable, and I also have to import one dependencies for data manipulation, just like this. And here I will write data set. Not like this, we can write it like laptops is equal to pd dot read underscore csv, and then you can click on this 3 dots, then copy path and paste that path here, and then run this. Create another cell, then laptops dot head for seeing top 5 rows, and it's like this. So Google Colab offers some steps, but I am not using that because if you are using this thing, the same thing in your own PC, then this thing will be not available, unfortunately. But I am using this right now. It says view recommended plots, and it will give you the plots. These are the plots. And by the way, these plots are creating with AI. I think now it's created. Now we can off them. I like this Google Colab features because this can do anything that you want. So let's go to our next step, and our data set is loaded. Now we have to build our model and train it. But before this, we have to do a thing here. We have to pre-process this. and I will simply process them. And the index is just 0 1 2 3 4. And is there any column else? Brand, just brand. We have to just pre-process brand and everything will be done for us. From scikit-learn dot pre-processing import label encoder, and L is equal to label encoder, and encoder le dot fit underscore transform laptops brand column, and it will return us laptops brand column again. And we can run this right now. And if we run this thing, if we see top 5 rows, then it's performed. We have brand. So after that, we have completed this part. Now we have to build a model and train that. So for that, I will use tensorflow dot keras dot sequential API, and here we can write the models. So I am simply importing everything. I am simply importing everything from tensorflow.keras.layers import stars. And after that, we can use anything. So I am creating a dense, and with the activation is equal to value. After that, we can use dense 2 comma activation value, and after that we can create a dense layer with single neuron. And because this is a regression problem, so we have to use activation as linear, and then we can run this. TensorFlow not defined. That's tf.keras. tf.keras.sequential. Now our model is created. After this, we can watch the model summary. Or we can ignore that also. We can ignore this thing, because summary just displays this all layers, but I don't like summary because it requires some parameters, so I am not going to go into that. So I am writing model.compile, and done. Here I will write the optimizer is equal to tf.keras.optimizers dot addon learning rate is equal to 0.1. I am suggesting 0.1 because I am not training this for very long time, so I am simply assigning it 0.1. But if you want a good model, you can use 0.01 as learning rate. And loss is equal to tf.keras dot losses dot mean squared error, and then metrics is equal to tf.keras dot accuracy, not here, it founded in dot metrics module, and you can write accuracy just like this. I think that's not accuracy, because accuracy is for classification. Then what is for regression? Let me remember. That's R2 score. That's R2 score. And after this, we can again click on plus code, then up button because it's created on downside, it's here, then model dot fit, but we have not created our x and y, so we will create that also. X is equal to laptops dot drop price from the axis of 1, and y is equal to laptops of price, then from scikit-learn dot model selection import train test split, and then x train comma y x test, x train comma x test, then y train comma y test train test split. From here, train test split x y test size is equal to 0.2. Then we can run this and let's see. P is capital. And if we run this, then we have done our train test split. Then we can train the model dot fit on x train comma y train comma epochs is equal to 10. I am just assuming for a test model, but if you want, you can train it for 100 or 1000 epochs, then it will work very gratefully. Here you can write the batch size also to 128. Let's assume that as 128. Let's assume that as 100. or we can assume that as 50. Then we can run this. Let's see what it will give. Our R2 score is in minus. But as I said before also, I am just assuming this as a test model, but if you want you can train it for many epochs, then it will work very gratefully. And after that you can click on plus code. Here you can again evaluate this model. So model dot evaluate x test and y test. It's like this. And if we try to train our model to 100 epochs, then let's see. It's very fast with GPU, so we can train this for thousands of epoch also. So let's see. And it's building. And if I go down, now we can stop this. So as you can see, our score is reducing. So I am just trying to quit this thing. So I will restart this thing. And if I click on yes, then it will be restart. Okay, now it is restarted. Now we can run it from the starting. So it's importing right now. It's imported. Let's run this cell. And it's again asking me for the file. So I will upload that file. And if I go to the downward, then this is that file. And then I can run this file. I can run this cell, and then this cell, then this cell, this cell, this, and we can simply train it for 10 epochs. then evaluate this. Then it is very high loss. As I say again, I am just assuming this thing. We are creating a test model, and you can create this model very with 100 R2 score if you will work at the epochs and landing rate. If you will adjust them, then it will be work. Then I am saving this file. So model dot save, model dot save, and model dot h5. And when I will run this thing, then it's created. And that's it, guys. This is the video. I hope you like this video. Thank you, guys. Thanks for watching the video.